In this video we're going to look at what happens whenever we generate the sine of the addition of two angles. So for instance, we have the sine of an angle x, which is shown here, which is just our sine function. But we're wanting to find out what happens when we generate the sine of the angle x plus another angle a. So if we were to generate this sine of x plus a, we've seen previously that if we had a function, say for example f of x plus a, then if a is positive, it's equivalent to shifting the function to the left, and if a is negative, it's equivalent to shifting the function to the right. So you'll remember seeing that whenever we looked at the section on functions and we looked at manipulating functions. So let's put this one in for the moment, and we'll change this value here to a value of 0. So the a is 0, so we're just going to be left with the value of our sine x. So it means that this one here is just going to sit on top of the blue one. Now, if we were to adjust the value of a, then we're going to get a different function. So if we move this along, you can see here that we're going to generate this function here, which is the sine of x plus a. And as we said previously, if the value for a is positive, it's equivalent to shifting the function to the left. And if the value of a is negative, it's equivalent to shifting the function to the right. Now, whenever we shift these functions over, the question is, how do we relate the new function to the old function? So, for example, we could look at this and we could say, well, the sine of x plus a, possibly that's just the same as the sine of the angle x plus the sine of the angle a, just multiplying out the brackets. But that's not the case, and we'll see that just now, because we're going to actually plot the sine of x plus the sine of a, and when we do that, you'll see here we get a different function. We get the function here in brown. So it means that we can see here that the sine of x plus a is not the same as the sine of x plus the sine of a. So the question we want to be able to answer then is, how do we generate this sine of x plus a? That is, how do we multiply out these brackets in order to give us the new function sine of x plus a? Well, let's have another look at this from a different angle. So we're going to look at that same problem from a different angle. We'll look at it in terms of our unit circle. So in this instance here, what we have are three angles. We have the triangle here, which generates the first angle. So we can say that's angle 1. We have the white triangle here, which generates a second angle, which is angle 2. And finally we have the pink triangle, which generates a third angle, which we can call angle 3. Now, I've set this simulation up so that the angle 1 plus the angle 2 is equal to the angle 3. So if we add up the blue angle and the white angle, we should get the pink angle. And you can see here, what I've done is I've generated the sine of each of these angles. Now, if the length of this radius is 1, then we know that the sine of the angle is going to simply be this height. So the sine of the blue angle is going to be this height here, which in this instance is 0.389. The sine of the white angle is going to be this height here, which is 0.717. And finally, the sine of the pink angle, which is this angle here, is going to be the height here, which is 0.932. Now, we've seen in the previous example that if we were to add the sine of angle 1 and then add on the sine of angle 2, we're not going to get the sine of angle 3. We're going to get a different value. So you can see here why that is the case. If we had the the length here, which is the sine of angle 1, and we add on the sine of angle 2, we're going to have this height here plus this height here. But that's not going to equal the sine of angle 3, because the sine of angle 3 is this height. And you can see quite clearly that this height here is not equal to that one plus that one. And if you were to shift this round a bit further, you could see that more clearly. So for example, the height here, which is the sine of angle 3, is not the same as the sine of angle 1, which is this height, plus the sine of angle 2, which is this height. So we're still left with the same problem. How do we multiply out these brackets so that we get the right answer? We know that sine of x plus a is not the same as saying the sine of x plus the sine of a. So how do we multiply these brackets out correctly in order to get the right function? Now what I've decided to do here is simply state the correct results. I will put the derivation in a video in the appendix section at the end of the course. I don't think it's worthwhile to add the derivation in here because it simply clutters up our understanding. So let's go ahead and we'll state the answer to this problem. And if you're interested, you can check the appendix section at the end of the course where you will find the full proof. So the first one we're going to look at is the sine function. So there's actually two formulas in here, and you can note I've got a plus and I've got a minus here, and a plus and a minus. What that's really saying to us is that if we were to look at sine of x plus a, then that's going to be equal to the sine of x cos of a plus the cos of x sine of a. Equally, if we were to look at sine of x minus a, then that's going to equal sine of x cos of a minus cos of x sine of a. So we've actually got two of the formulas here. So whenever we add sine of x plus a, it's not just the same as saying sine x plus sine a, as we've seen. It's going to be given by this formula here. Now we can do the same with the cosine function. And the cosine function gives us something slightly different because the plus and the minus get swapped round about. So if we had cos of x plus a, this is the same as saying cos of x cos of a minus the sine of x sine of a. And if we had cos of x minus a, then this is the same as saying cos of x cos of a plus sine of x sine of a. So there's actually two equations here. So although we've only shown two of these equations, there are actually four of them whenever you take care of the plus and minus signs. Now the equations written here might not mean an awful lot to you at the moment because one, we haven't proven them, so you don't know where they've come from, and two, we haven't used them. So rather than work through a complicated proof, the best thing for us to do is to go through some examples of using them, and we're going to do that on the next video.